Another crazy Englishman, and he came over here fairly recently, and he's got a job in Kansas in the Geological Museum there. And he's also an amateur spider freak. And so him and Bill Shear, who's another arachnologist, were messing around in a place called Gilboa in New York State. And these are old, really old peat bogs. And so, cut a long story short, they were taking strata of peat, taking it back to the lab and throwing it in some kind of acid bath. I don't know what the acid was, but the acid would eat the matrix, and they were looking for evidence. They're both interested in paleo environments. They're both bug people, right? So they were interested in what's living at this particular time. So what would happen is that all this stuff would float up to the top of these buckets with acid in there, and they would go in and they would sort through it and look at it under the microscope. These were 400 million years old, and they weren't fossils. It was the actual cuticle that had been pickled in a peat bog, right? It's just unbelievable. And one of the things that they found that just blew their mind, they got one of these little pieces of cuticle out, and they were looking at it, and they were like, what are those funny CD on there? And they took photographs and measured, and you know what CD are now, right? and they were so distinctive. They were like, they're spinnerets, spigots. How can that possibly be? This deposit is 400 and whatever it was. I think it was 30 million years old. And then they found some more. They started looking more carefully, and they found some more. And these were the first evidence of the synapomorphy for the order Araneae, right? So the use of posterior spinnerets covered in spigots producing silk is a unique synapomorphy for spiders. No other group has ever evolved that. So they were like, this is incredible, you know? So they looked a little bit more, and all they could get were fragments of this cuticle with these and the spigots. It looks like maybe like the finger of a glove with a, you know, they kind of look like this. They come up to, they're conical, and then there's a single nozzle on the end. So they're really, really distinctive. And what they constructed, they described a new species called Atacorpus fimbriagus from this deposit in Gilboa. And they described, and he drew, and he tried to reconstruct this thing, and they couldn't come up with any other supported explanation than this thing was probably covered with these CD on its legs. Yeah, it was just, I mean, if you're into spiders, that's like mind-blowing, you know. I mean, it's just like, so when he published this thing, people were very dismissive of it, but they tried to find, not of the fact that they had found spigots, which by definition means that these things produce silk, which means that they must have had, but like modern spiders have them all in one place. They have them on the spinnerets, which are posterior on the end of the, you know, the bum end, and but this thing appeared to have them. So we have evidence of a synapomorphy, and I've seen the slides of this thing. I mean, I've actually seen the cuticle. You can pick it up and touch it. It's 400 million years old, not fossilized. It's like somebody just took it off yesterday. It's unbelievable. How did they get onto that? What was the question?
Because we were talking about silk production and what it was used for.
So we know that spiders produce silk. We know that the modern spiders in that group only live in burrows. And if we look today for evidence, so this is the sort of comparative side of the historical method, look for something that shares other characters and see what they do. But there's nothing else that these could do but live in burrows, because they're big and fat and heavy with short, stubby legs. They can barely, you know, run. And so if you put all that evidence together, the next use for silk would be if you put just 2 or 3 lines coming out of that trap door, out of that burrow. It's not a snare, it's a trip line. So an insect now, you can feel it coming from a foot away. And so if you're in your burrow and you hang onto those lines and an insect trips that wire, you can be up out of that burrow and grab it before the... So that was the next iteration. And that was pretty much it for 250 million years until these insects started to do their thing. And then what was selected for was lighter bodied spiders that produced some kind of silk that was some sort of snare. So then it goes to various types of snares, sheet webs, funnel webs, tangled webs, clam webs, right?
Yeah.
Clam webs.
Clam. What is it? What did I say?
Crab.
Clam.
I know,
yeah,
but
yeah.
what it was? I renamed it.
Calamaria? Calamaria?
Yeah, that's the clam spider.
Calamaria, yeah.
Yeah, it's calamari, but you've named it the clam spider, so that's what it shall be from now on. And so all kinds of variations on that theme. But then secondarily, a lot of spiders moved away or were selected against the webs, and I have no idea what that's about, but it's related to other morphological characters, like the fact that web spiders have 3 claws and ground spiders only have 2. And that could be really difficult to find, right, Paula? Yeah. In the lab it can be. But that's associated with them, and better eyesight. Because spiders live in a vibrational world, eyesight is meaningless to them. Spiders detect light and dark and some movement, and that's about it. All the web spinners do. So their world is, they have 10,000 CD on each leg that they can sense their environment, the pheromones, the chemicals, the moisture, the vibrations, the courtship. It's all done through the web. But then there are certain groups of spiders that, of these 8 eyes that they have, that are nothing else but simple lenses, evolved the front eyes into being highly, highly acute. Now we say that the cephalopod eye is the most highly evolved and derived invertebrate eye. Remember, there's no such thing as invertebrate, so that doesn't make much sense. But there's evidence to suggest that these jumping spiders see just as well as we do. They see stereoscopically. They can tell the difference between conspecific males on a Walkman. You remember Walkman? The TV version of the Walkman.
Yeah.
What were they called? And then the Walkman was like this, right? And then you came out with these things where the screen was like that big. You remember those?
Yeah.
Am I dating myself now? Well, they were a big deal for one time. People walking around watching The Simpsons and things on these little tiny screens. If you put one of these spiders in front of one of these screens and show it a courting male of a conspecific species that's exactly the same, that we can't detect hardly any difference. Their eyesight is so good that from 6 inches away, the females can differentiate the signals of a male on a TV screen. So their eyesight, and you could do this yourself. You've all seen them running around, the jumping spiders. These are the hairy, brightly coloured diurnal ones. They're only around in the day.
Like
you go there and put your finger close to it, and they'll just sort of pick their head up, and they'll kind of follow you around, and they'll check you out, and they've got eyes like headlights. I mean, they're huge.
So cute.
Huge. They are cute. Yeah. All spiders are cute, but maybe they're a little cuter than others. But so that group, the only time that they ever use silk is for the male to spin a sperm web and to molt them. That's it. And a drag line. All spiders always have a drag line.
Does the female encase the eggs once they've been fertilized?
Yeah.
Yeah.
Okay. She'll make a little saucer of silk, and I hope to show you that when we go out at night too. And it's usually crimson red, salmon pink. Salmon pink would be more. And she lays the eggs in a little glob in the middle and then covers it over with silk. It's the most amazing thing to see. And then often, depending on the group, she'll go out and start picking up this kind of stuff, lichen, and incorporating that into the silk. So when it's finished, it's so cryptic that you can't see it. It's just really, 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 really amazing. So bungee cords was the other thing. All spiders use a bungee cord.
Right, okay, so a safety net.
Right.
A safety cord.
And particular in the jumping spiders. They never ever jump.
Right.
Unless
right.
you see them
You've
constantly
first.
dabbing their butt on everywhere they go. They walk, dab their butt, and what they're doing is putting down a drag line and securing it. And so if they jump, 6 to 10 inches and miss, no problem. They go on a bungee and then they come back up. So that's another one. And then within any given orb web, there's about 7 different types of silk in that orb
Right.
web.
I'm just thinking of an activity of kind of like the